Hey everyone, this video is for those who are new to AI engineering or exploring AI and LLM models. If you happen to be an experienced AI engineer, you may skip this video as we will be covering just basics. So what exactly we are building today? We are going to build a simple insurance AI assistant. So we'll keep an insurance company for this demo, a dummy insurance company. A customer can ask questions like policy expiry date, policy status, or coverage details. So instead of making up answers, our AI agent will call a Python function. That function will read the customer information from the CSV file. In this demo, we are using that CSV. We are wanted to keep it very simple. So in production scenarios, it can be a database or it can be an CRM application or different applications. So finally, the LLM will convert the data into a natural language process. Although this is a simple demo, the architecture is very similar to what we see in enterprise AI applications. Before we start coding, let me quickly show you the development environment. Everything in this video runs on my local laptop. I'm using Visual Studio as my editor. You can use your own choice, like PyCharm or any other thing, and Python for development, JIT for version control, Ollama to run the LLM's model locally on my laptop. So those who are not familiar, what is Ollama? Think like Ollama as a VLC player and model as a movie. So you need a VLC player or any other media player to run movies locally on your laptop. So Ollama does that for you. In this demo, I'll be using Meta's Llama 3.2 model. So you can use any other model if you prefer. The concept that we will discuss remain exactly the same. Okay, let me walk you through Ollama, which is installed on my laptop. So this is the version Ollama 0.32 I'm using for this demo. And I'll list down the models which is installed currently on my laptop. It is Meta's Llama 3.2 3B. And this is the model which I have installed 10 days ago. I've been playing around with it a lot. Let me invoke this model from my laptop. So remember, when I'm invoking, it is not reaching any cloud service. It is completely on your local laptop. Okay, that model is invoked. Let's ask a few questions. Let's say, what is your knowledge cutoff? It does answer it. It shows that it has been trained until December 2023. So that was the trained data. It is trained. So let me ask few more questions to it. It's not going to answer because it doesn't know it yet. Let me rephrase the question again. Okay, but it does know the past data, which is it is trained on. So let me ask a real-time question to it, like what is the weather today? So as expected, it should not answer it because it doesn't have access to the real time, because this is the place where AI agents comes in. So we're gonna give an intelligence to the LLM to call an tools whenever the user asks certain real time questions. So let me ask other question with respect to our demo, like general policy. Before writing any code, let's first understand the architecture. This is probably the most important slide in this video. A normal chatbot receives a question and generates an answer, right? We have seen in our previous video where Amazon Lex chatbot on Bedrock responds to the customer queries and reads the data from the vector database. So here we are simulating an AI agent. So an AI agent goes one step further. So it takes the action. In our case, that action is reading a policy information from a CSV file. So the customer asks a question, the LLM analyzes it. If business data is required, it calls a Python tool. That tool retrieves the data. Finally, the LLM explains the data back to the customer in a professional manner. It's not reading the data it's not giving the output in JSON format. This simple workflow forms the foundation of almost every AI agent out there. This demo AI agent is intentionally kept very small, so that it can give us an foundational knowledge why LangGraph or LangChain or frameworks are really required. So and what problems it can solve. So we'll discuss that later in this video. So this think of this like an old traditional way of creating and manually creating an AI agent in automation. So here in this project, we have an app.py file which acts as a main application, a tools.py file where our business functions are written, and a prompts.py file that defines the behavior of our AI assistant. And finally, a CSV file containing our sample data. So keeping the project simple helps us understand every component individually before moving to enterprise architectures and production scenarios. So let's start with the simplest part of our AI agent. Every AI application starts with a conversation, right? At this stage, our application is simply taking user input and sending it to the LLM, running locally using Ollama. If I ask a normal question, the LLM can answer it because it already has general knowledge. So we saw that it is trained till December 2023, right? But this is still just a chatbot. It doesn't know anything about our customer data. It doesn't know our insurance policy based on our use case, and it doesn't know our business policies as well. So to convert this chatbot into an AI agent, we need to give it the ability to perform certain actions. So that's nothing but a tool calling in our example. So that's exactly what we are going to build in the next section of this video. So this will be my working environment inside Visual Studio Code. So I'll be using Python version 3.14. And I'll be using UV as my package manager. So this is a version of UV. So most of the agentic solutions, modern agentic solution uses UV as a package manager. So you can use PIP as well. So let me create a virtual environment before writing anything. So this is my virtual environment, which is created. So, and it does have an activate script as well. So let's proceed in activating this virtual environment. All right, our virtual environment is activated. Yeah, agent, this is our working directory. Now let's initialize our environment. So it is successfully initialized. So it creates a project toml file. So this is the file which it contains all the dependencies and the project description and the version control. So later on, we can refer to this file again and see what and all packages are installed. So let's start with installing a few packages here. So we might be needing Llama package as well. Try, let me, okay, our Ollama package is gonna be installed, and yeah, it's installed. Let us install LangGraph as well. So we will not use LangGraph for now, but for the package to be updated, so we'll install LangGraph. All right. Let's add Boto3 just for the testing. So this Boto3 is a library package which will be used for AWS services. So to connect to AWS services. So we're gonna use the same AI agent in future to connect AWS services as well. So let me bypass the safety check of PowerShell with this command. So it will allow me to run this my Python scripts. And we'll add one more package request, so which will allow us to interact with external APIs. And let's start with committing our first Git commit. Let's add the files and let's do our first Git commit. Initial project setup. Let's do it. Done. I'm an occasional coder myself, so I won't be explaining the code line by line. Instead, we'll go through the script at a high level and understand each stage of what we are building today. So you can find the link to all the scripts used in this video in the description below. Feel free to use them as part of your own learning journey. Okay, let me paste the code here, which I already have. So first in this code, as you can see in this code, we are calling Ollama import chat. So we are calling the package here in our Python script. And the first function, what we'll be calling here is the chat function. In the chat function here, we'll specify to invoke a Llama 3.2 model. So this model will process our prompts. Inside the message, we send the message with the role as a user and the content. You think this as the question we are asking to the AI, and finally we print the AI's answer using response message content function. All right, let's test it out now by running our script. App.py, let's run this, our first script. Yeah, you can see it is invoked. The chat function has invoked and it is calling the AI assistant. So we can input our questions here. So let me test it out with hi. So it's gonna respond. So let me ask the same question which we saw previously. What is your knowledge cutoff? So it's gonna respond. So you can see in the back it is idle right now, but in the back end it is processing. So this is part of our learning. So we'll fix this. This is called as a streaming response. So we'll fix that in the next section of this video. So let me ask another generic question. So let's say what is Amazon Connect? So it's gonna take time. So it is processing its own trained data and it is searching in the backend. So it's gonna give us an output as soon as it finds an answer. Our first milestone is complete to invoke an interactive chat. So from now onwards, for every milestone, we'll keep app.py in a different version. So at every stage, we'll keep appending the same code in a different file. So it will be easy for us to understand the different stages of AI agent. So for this milestone, let me save it as interactive chat and I'll create a new app.py file. So we'll use the same code and keep appending at every stage. Currently, every question is sent to our model as a new request. The model does not remember any previous conversation. So each question is treated as independently. So let me show you an example here. So I'll ask the model, I'll say my name first to the model, and it's going to respond to my request saying that nice to meet you. And I'm going to ask what is my name again. So it doesn't it will say it doesn't know. So this will move to our next topic. We will introduce a conversation list. Every user question and every AI response is stored in this list and sent back to the model with each new request. Because of this, AI remembers the previous conversation and can respond based on the context. So this is called maintaining a conversation history and maintaining a conversation history or context. So it is stateful because it maintains the conversation history. Now let's test it out by running our code app.py. So we'll invoke the chat and I'll feed in with my information here. Let me feed in my name first. Send a response. I'll feed in more information like where do I live, and I will also feed in like what is the weather today. Let me feed what is the weather today. Okay. Done. Since now it knows our information, so let us ask if the model can maintain a conversation history. Great. It does knows my name and where do I live, and it knows the weather. So it's maintaining a conversation history now. Okay, so we are done with this milestone. We'll save the same file and create a new app.py for our next stage. Now the AI remembers the conversation history. So let's proceed to adding system prompts. So we'll add the system prompt at the beginning of the conversation. So this tells the LLM who it is, what its job is, and rules it should follow. So now, instead of acting like a general purpose AI, it behaves like an insurance customer agent. So based on our use case here, and responds according to the instructions we have given. In short, we are just adding an behavior and control to our AI model. So let's test it out now by running app.py. So I'll begin with asking a generic question to the model. Let's say I'm just asking, there's a typo there. So let's see if it can respond. Okay, good. It does say that it provides information about insurance if needed. So it is understanding our behavior, so what we have written in our code. So let me ask another question, which is inside the context of our use case. For example, what is general insurance policy? So let me see, it should describe it. Yep, there it is described. So it's working now. Let's save it. Now let's enable streaming responses. So what will happen is we'll introduce a parameter here, stream through. This allows the AI to send the response token by token. So the output appears on the screen as it is being generated. So this gives a much better user experience because the user doesn't have to wait for the complete response from the model. In short, it is just streaming the response in real time. Is the print message, which will print the responses in real time. So let's test it out now. Py app.py. Just given, yeah, you can see the responses are given in real time. So let me ask a question, which is inside our context. What is Yeah, it's streaming the response in real time. So it's much more better user experience. Until now, our AI could only generate responses based on the prompts and conversation history. This is our code for the tools.py. This is the place where we are importing pandas to read the CSV data from the data folder, which we have saved. So now let's introduce our first tool. We create a get policy function that can read customer policy details from CSV file. We also define the tool's name, description, and input parameters so that LLM knows when and how to use it. In short, we are taking a first step towards building an AI agent by giving the LLM access to the external tools instead of relying only on its built-in knowledge. Now let's understand the system prompts. This system prompts is where we define the AI agent's behavior. Here we clearly tell the LLM its role, the task it can perform, when it should use the get policy tool to read the data from the CSV and the rules it must follow. This helps keep the responses consistent, professional, and within the insurance domain. In our use case, we are working on it. So you can think of an other use case during your production scenarios. In short, the Python code defines what the AI agent can do, while the system prompt defines how the AI agent should behave. Okay, now let's proceed to introduce a tool calling. So we register our tools with the LLM using the tools parameter. So I have my code ready here. So when the user asks something that requires customer data, the LLM can decide whether a tool should be called or tool should be used before calling and which tool to be selected. So if we have multiple tools registered, so we can call one by one each tool. Let's test it out. Let me run. I have already the code pasted here with the tool calling. So let me run the app.py. So let's say hi. So yeah. So I've just for the debugging purposes, I have enabled JSON output so that to just identify whether the tool calling function is working fine or not. So in the next section, we'll just remove that and we'll see how the tool calling function works. So you can see get policy, it's using the tools.py and prompts.py function. And a little bit of a break here for the debugging purpose. Let's understand what actually happened behind the scenes. Every AI agent follows a very simple cycle. Reason, act, observe. First comes reason. The LLM analyzes the user's question. It decides which tool should be used. So in our case, we'll be calling a tool to read the CSV data, right? Next comes act. Here, Python executes that function. In our case, it reads the customer policy from the CSV file. And finally comes observe. The tool returns the result. The LLM receives that result and converts it into a professional response for the customer. So this is the foundation of almost every modern AI agent. So whether you are using OpenAI, Anthropic, Amazon Bedrock, or any other platform, the basic pattern remains the same. All right, I have my code ready, code copied. So I'm skipping one section here, guardrails. So because we'll be covering that guardrails over here. So I have implemented in this code guardrails. So guardrails acts as a filter or keyword filters that allows your AI agent not to do certain nonsense responses. For example, it can also help you in optimizing the cost if you are using an expensive LLM. So I have the tools function in place. I'm still printing the output in JSON format just to have a clear clarity that it is calling an tools function, get policy tools function, and it is selecting the tools and it is reading the data. So let's test it out. App.py. Let me put see based on the guardrail input, so filter. So it is just acting like it's gonna say that it is only restricting its responses into an insurance AI assistant itself. Let's say let me ask a question related to our context as we seen in the past. So it's gonna respond. But here, since we are giving an tool calling function in JSON output, so you can see so the tool policy get policy tools is selected and it is calling the tool function. And it is also passing through the guardrails. So before choosing the tool policy, it has to pass through guardrails. So let me ask a question related to our policy. So when does our policy expire? For example, this is the data from our CSV. So, and it successfully extracts all the customer details. For example, this customer is fully covered. So and so, and you can see it has selected the policy and the policy has been found. So this is the tool result. So in the next stage, we're gonna transform this response into more human readable format. So let me ask one more question with the policy which is not there in the data. For example, 1, 2, 3, and you can see it is finding, it is reading the whole CSV file, and it is telling that this specific customer is not found. Okay, so I have hallucination fixed. I'm skipping that section. So let's straight away test it out, our final AI agent, final test. So here I'm gonna ask what is my policy. So you see the pattern here. So it's gonna also remember have the short-term memory as well. So remember we implemented that at the beginning. So you can see that it is reading the data, it is calling the tool, and it is giving the data information in an human readable natural response. So it is telling like you have comprehensive platinum motor insurance policy. It is basically reading the data from the CSV. And when I ask what is the deductible amount from the policy, it does give me the result as well. It says that $50. So this is my sample data just to verify. You can see that 50, this first row is the policy number which I had asked. So it is reading the data from here. So, and there you go, our first AI agent working successfully. Great. So far, we have built a simple AI agent that reads our customer information from a CSV file. But in real production environments, we normally don't read the data from CSV files. Instead, that AI agent connects to enterprise database, REST APIs, or CRM systems, or payment gateways, authentication services, or knowledge bases. Based on any use case which you have. The interesting part is that the overall architecture remains exactly the same. Only the backend system changes for every different customer environment and requirements. Today, we are calling a Python function that reads the CSV file. Tomorrow, the same function could call an enterprise API or query a production database. This is why understanding the fundamentals is much more important than learning any specific framework. Why workflow orchestration framework exists? So during the development of this AI agent, we encountered several practical challenges. Our application started to grow into a single large Python file, right? Managing conversation state became difficult. So adding multiple tools also increased the complexity within the code, and debugging also becomes more difficult because everything what's happening inside one application was difficult to analyze it. So this is exactly where workflow orchestration framework becomes useful, like LangGraph or LangChain. So frameworks like LangGraph don't make LLM more intelligent. Rather, they solve the problems which we face. Like they don't improve the reasoning, and they don't remove hallucinations. Their primary job is to organize the workflow. So they help us the application into multiple independent steps, manage shared state, simplify debugging, and make the application easier to scale. Think of it as moving from one large Python script to a well-organized workflow. So I've used other orchestration tools as well. So for example, if you are a beginner, you can always try Zapier. So it is an amazing tool. You have an unlimited access to it at no cost. You can create plenty of AI agents there. And if you want to go beyond a little bit advanced, like calling webhook APIs, so you get a paid version of it, paid subscription of it. It is at very minimal cost, what I say. And N89 is also out there. It is a little bit of advanced, and a lot of templates available out there in N89, where a lot of developers have developed already the workflows, where you can utilize those workflows templates and use it into your use case. And if you happen to be an hardcore developer or who is working on an enterprise grade applications or agentic solutions, so you can utilize LangGraph framework. So, and combining this LangGraph framework with Amazon Bedrock Agent Core exposes you to a more bigger ecosystem of AWS. You can utilize native AWS services to think of a solution or create an agentic solutions based on the use cases. If you are starting your AI engineering journey, this is the learning path that I personally recommend based on my experience. Start with Python, learn how large language model works, understand prompt engineering, build a simple AI agent. So like this, for example, calling a CSV, reading the CSV data, or calling some APIs. So learn tool calling, understand memory and state management, then move to workflow orchestration frameworks like LangGraph. and finally explore cloud AI services and enterprise AI platforms. If you follow this order, believe me, every new technology will become much more sense because you will already understand the building blocks behind it. Before we finish, let's commit our project to GitHub. Version control is an important part of every software project, so including AI applications as well. It helps us track changes, collaborate with others, and maintain different versions of our AI agent. This, this brings us to the end of this video. In this session, we built a basic AI agent completely from scratch. Most importantly, we understood the core concepts behind AI engineering instead of relying on frameworks. Now we get an idea why LangGraph is used. In my next video, we will take this same AI agent and gradually evolve into an enterprise-grade architecture. Maybe use a different use case or integrate APIs or different enterprise applications like CRM. We'll introduce workflow orchestration concepts and see how they simplify complex AI workflows. Thank you for watching, and I'll see you in the next one.